hope you are doing great. Today we are going to solve the InterviewBit time complexity section, first bucket. Now let's move on for the first problem. Here we are given the problem, a block of code. You have to write the equation of number of instructions from this code. Just give me a minute. I'll take a screenshot of this and put it in this. Yeah, I hope you can see this. Now you have to write the number of instructions equation. Number of instructions. So how many instructions are getting executed in this function or at the block of code? Here are two instructions. This loop is executing n times, so n instructions are getting executed, and this loop is executing m times, so m instructions are getting executed. So number of instructions is equal to n plus m plus 2. Now how will you find the big O notation of this equation? You eliminate the constants and you eliminate the lower order terms. Here we don't have any lower order terms, both have the degree 1, so this becomes big O of n plus m. I hope you understood the solution. Let's move on to the next problem. Now let's just take the screenshot of this. Yeah. Now write the number of instructions equation for this problem. Number of instructions is equal to. So these are two instructions, and this is an instruction which is executing n times. This loop is executing n times, and this loop itself is in another loop which executes n times. So total, how many times is this instruction executed? N into n square times. So this total will give us n square. You forget this. And then coming to this loop, how many times will this instruction be executed? This will be executed n times. So the number of instructions equation will be n square plus n plus 2. How will you find out the big O notation? Big O notation is eliminate the constants, eliminate the lower order terms, which is big O of n square. Let's move on to the next question. And space. We are not creating any arrays or we are not creating any data structures, so it's O of n space. Time complexity is O of n square and space complexity is O of 1. Next problem. Now write the equation. Let's call it f of n. Why do you write number of instructions every time? Let's call it f of n, where f of n is number of instructions, and this instruction is one time executing. This instruction gets executed here. Now here's a tough one. Not actually tough, but let's see. For I is equal to 0, how many times will this loop be executed? It executes n times. And for I is equal to 1, it executes n minus 1 times, and then n minus 2, and so on, until I becomes n minus 1, and this loop will be executed once. So you have this. This is nothing but, if you know, this is sum of natural numbers, 1 plus 2 plus 1 to n. Sum of natural numbers is n into n plus 1 by 2. So this instruction is getting executed how many times? N into n plus 1 by 2 times. And this instruction is getting executed one time. So f of n is equal to n into n plus 1 by 2 plus 1, which in turn is n square plus n, just ignore the constant, n square plus n plus 1. You just ignore the constants and lower order terms. This is O of n square. And we are not utilizing any space except the variables. We are not creating anything. So this is O of one space. O of n square time and O of one space. I hope you got it. Let's go to the next problem. This is O of n square time. Next question. And I think it's the last one. Good going, guys. What does it mean when we say that an algorithm X is asymptotically more efficient than Y? Now, this question is a bit theoretical, but I'll try to explain it to you. Wait a minute. Yeah. Now, there are two functions. This is n, this is f of n. There are two functions, let's say one function is constant and one function is linear. This is f of n is equal to n, and this is f of n is equal to constant. Now let's say this n naught. Until n naught, f of, let's name these functions. This is the first function and this is the second function. Until n naught, second function is greater than the first function, isn't it? And after n naught, at n naught, both are equal. And after n naught, f of the second function is less and the first function is greater. So basically, don't care about the smaller inputs. We just care about the larger inputs. How is the function growing for larger inputs? So we only consider for larger inputs. So what can we derive from this? For larger inputs, the second function is less effective compared to the first function. So the question is asking that, what does it mean when we say that an algorithm is asymptotically more efficient than Y? So X will always be better choice for larger inputs. For larger inputs, X will always be better choice. Because if a function is growing rapidly compared to other functions, even though it may be less, its value may be less for initial values, but as it is going faster, it is definitely going to beat the other function and be greater than it. So the function which grows with less space is the efficient function. Yeah, I hope you understood this point. And this is all for this video. We have completed a bucket from time complexity section. Thank you very much for watching this video.